All right, ladies and gentlemen, welcome back. These were the two problems that you were supposed to do on your own, so let's go ahead and do them together. Here we have root 4 of 27 times root 4 of 3. And so we're going to take the 4th root of 27 times the 4th root of 3. And that's going to be the 4th root of 81. That's a really big dip there. But so what number times itself 4 times is 81? That would be 3. For number 6, we've got the cube root of 250 divided by the cube root of 2. This is going to be the cube root of 250 divided by 2, which is the cube root of 125. And what number times itself 3 times is equal to 125? That would be 5. All right, if you have any questions on these, make sure you ask. Otherwise, let's go ahead and move to the next set of problems where we write radicals in the simplest form. So again, recall, we did this back in chapter 4. We would simplify the square root of 48. And remember, this wasn't a perfect square. So we looked at our list of things that were perfect squares, right? 4, 9, 16, 25, 36, these numbers. And we said, which of these numbers is the biggest one that multiplies evenly into 48? And we found that it was 16. So it was root 16 times root 3. We split it up into those two radicals, those two roots, to find the largest square root that multiplied into it. And then we simplified that, and we ended up with our simplest answer. Okay? Now, we're going to do this same thing, but we're going to do it with cubes and 4th powers and 5th powers here in just a second. Part B, also recall that you're not allowed to have a radical in the denominator. And the idea was that we multiply the root by itself so that we ended up with a root in the denominator that was a perfect square. And the reason why that was important is because when we took that perfect square, we ended up with a number that wasn't a root anymore. So that would give us our final answer. Now again, we're going to do this same thing, but we're going to do it with cubes and 4th powers and 5th powers. And so instead of the goal being to make it a perfect square, it's going to be to make it a perfect cube. So let's go ahead and look at some examples with the higher powers. Here we have the cube root of 135. And we need to write this in its simplest form. So the first thing we need to do is figure out what is the largest cube that divides it. Excuse me, I got the hiccups all of a sudden. That divides evenly. So just like we did on the previous one where we looked for the perfect square, now we're looking for the largest cube. So it's nice to have a list of cubic numbers next to you. If you don't have them, we've got 1, 8, 27, and then what's 4 cubed? That's 64. So then we want to look at these. Do any of these ones that we've put up so far divide evenly into 135? So 135 divided by 64, no. 135 divided by 27, yeah, it does. 27 works. If you take the cube root of 27 and multiply it by the cube root of 5, you get the cube root of 135. Which is great because we can split up the cube root of 135 into the cube root of 27 times the cube root of 5. And I know the cube root of 27, it's 3, which means the simplified radical here is 3 times the cube root of 5. So notice it's the same idea. I'm splitting it up. But instead of perfect squares, I'm doing perfect cubes because this is a cube root. That means that for number B here, we're going to have to do perfect fourth powers. So again, if you don't have a list of perfect fourth powers next to you, we might be able to help you out. I got, let's see, 1, 16, and 3 is 81. We're already getting maybe a little too big, so let's hope 16 divides. So we're going to look for the perfect fourth power that multiplies into 128. I bet it's going to be 16. Hey, look at that. The fourth power, the fourth root of 16 times the fourth root of 8 equals the fourth root of 128. Notice I used a perfect fourth power this time instead of a perfect cube because it's a fourth root. Well, this is 2, so my simplified answer is 2 fourth root 8 because I took out a perfect fourth power. Okay, I do have some practice for these on these ones, but let's do a couple of the division problems, and then I'll send you to go do that. All right, so again, we have a fifth root of 8 in the denominator, and we need to make that something that is not a radical anymore. And the goal here is, what can we multiply 8 by to make a perfect fifth power? Remember, back here we multiplied to find a perfect square. It just so happened that it was the same number. But we could multiply it by anything that made a perfect square. Now we need to make a perfect fifth power in the denominator. So I have to multiply 8 by something to make a perfect fifth power. Well, again, we need to know the fifth powers. We got 1, which is always there. 2 to the fifth is 32. 3 to the fifth is 243. 4 to the fifth is 1,024. So the question is there any number that I can multiply 8 by to get to 32 or 243 or 1024? And as it turns out, there is. 8 times 4 equals 32. So I'm going to multiply the top and bottom by the fifth root of 4. Because if I multiply by the fifth root of 4, I get the fifth root of 32 in the denominator, which means that I can simplify the denominator to 2. And so this is going to be the fifth root of 28 over 2. And I don't have a radical in the denominator anymore, so I'm done. Let's do the same thing with this one over here. What can I multiply 4 by to make a perfect fifth power? Again, this is a fifth root, so I need to make a perfect fifth power. 1, 32, 243, 1024. Look, it's the same one here. If I can make 32. If I multiply the top and bottom by the fifth root of 8 this time, the denominator becomes the fifth root of 32. The numerator is the fifth root of 24. That doesn't affect what we're doing. But having the denominator be a perfect fifth power lets me simplify it to a 2. And I get my final answer. This is a 24, by the way, not an 8. Okay, that's the last of the examples here. There's definitely some practice that you're going to want to go take a look at. If you got questions, give it a try. Let me know how I can help you out, okay? But we'll see you in a couple minutes with the other examples.